So the problem that students face when they are tackling the differential equation is that they don't know how to tackle the main shifting of the variables. Now, one of the interesting relation that exists between acceleration and velocity and time is, we all know that acceleration is dv by dt. Acceleration is given by dv by dt. But suppose now, what if I'm writing, if I have to write down this acceleration in terms of displacement? We know, okay, acceleration changes with respect to time, but if I want to define acceleration in terms of displacement, how can we mathematically do it? What is the logic? What is the rationale, or what is the way to do that? So when you're talking about acceleration and let's say uh, the velocity relation is given by dv by dt, and which we can write down as dv by ds times ds by dt, which is like your chain rule kind of stuff. This ds and ds anyway get cancelled and gives you dv by dt back. And if you remember that ds by dt is the velocity function, so the acceleration can be rewritten as, because this function that you have here is nothing but velocity, so acceleration can be written as v times dv by ds. Now this becomes one of the very, very interesting result. Acceleration in terms of displacement. Now what kind of question will be asked? I'm giving you one of the IB exam question. So here we had given that velocity of a body is given by um, 1 negative 1 over s cube, and you have to find out acceleration of the body. What is the acceleration when s is 1 meter? Here the unit of s is in meter. So this was the question. Now lots of students, they differentiated this result in terms of time because they didn't know this about this result, v dv by ds. So if you know this result, you automatically get the answer within seconds. And this question was like 5 to 7 marks. So when you have this expression, keep it in your mind because this is very helpful result. Now v is negative 1 over s cube. This can be written as negative s to the power negative 3. So first find out dv by ds. Like you can see that v's right hand side is in terms of s. So dv by ds will be negative of negative 3. That becomes positive s to the power negative 4. So it'll be 3 over s to the power 4. Now you're going to plug this out here. So acceleration function will be, velocity function is negative 1 over s cube times, so this v I replace with here, and dv by ds is 3 over s to the power 4. So it is negative 3 over s to the power 7. That's your basically the displacement function, I mean acceleration function in terms of displacement for this given problem. And next up is you just plug in the s value as 1. So here acceleration will be negative 3. So negative 3 unit per second square. So whenever you have been given such a relation, it is important you remember this. And obviously, I'll try to give a couple of more practice questions in our regular classes where this relation is applied to solve some challenging differential equation problems.